Which side would we say is more complicated?
Uh, I'd say just on the surface, it looks like both are about equally complicated. But in general, it will be easier for us to work with a binomial like this and get it to become a monomial like that, as opposed to working with the monomial and making it become a binomial. That's not always going to be the case, but for this it will. So we should actually start working with that left side. All right. But the issue with this one is when we have a binomial, typically we want to get a common denominator, right? Okay. Well, the denominator of both of those is already 1. So the question is, can we rewrite those in some way, shape, or form so that their denominator is not 1? And there's 2 ways we could do that. One way would be to use the reciprocal identities. You could write tangent as 1 over tangent, or 1 over cotangent. And cotangent is 1 over tangent. The other option would be to rewrite them using the quotient identities. So you would pick one and try it out. All right. So I would go ahead and try it out. Maybe we'll do the quotient identity. All right, so I'm going to say for the left side, I'm going to rewrite it as sine x over cosine x, because that's what the tangent is. And then cotangent is cosine x over sine x. Okay? Now, from there, we need to get a common denominator. The common denominator will be cosine x, sine x. So you provide each portion with what it needs. This part needs sine x. This portion needs cosine x. So once we do that multiplication, we will get sine squared x plus cosine squared x over, since the denominators are the same, we can lump all of this together, be over sine x cosine x. Okay, and then once we combine that left side, in the numerator, that is our primary Pythagorean identity, right? Sine squared plus cosine squared is equal to 1. So we end up with 1 over sine x cosine x. And again, we always want to keep in mind what we are trying to get to. All right, we're trying to get to secant x cosecant x. Well, secant is the reciprocal of what? Cosine. All right, we have a cosine in the denominator, so that's good. And cosecant is the reciprocal of sine, which is also good because we have that in the denominator as well. So we can bring both of those up to the top, and when we do that, they will become their reciprocals. So we'll end up with cosecant x secant x, which is equivalent. I suppose we could rewrite it in the same order, but they are the same thing, so all is good.